Okay, so let us continue with the second part of problems. In a turning operation on stainless steel with hardness 200, the cutting speed is 200 meter per minute, the feed is 0.25 millimeter per revolution, and the depth of the cut is 7.5 millimeter. How much power will the lathe draw in performing the operation? So for this one, it is the same as the previous. We will do a comparison with another case where the thickness, the feed is different, okay? So let's say here we will repeat the same problem, but with a feed of a different feed, so different T0, okay? So in case the feed is different than 0.25, we will have the same problem, just we change the feed. Because the feed changed, first, we should calculate again the removal rate. So the removal rate will change, plus that the specific energy U, we cannot take it as it is from the table, 2.8 joule per millimeter cube. We should multiply the value we got, which is 2.8, by the correction factor. So now what we will do is that we will find what will be the correction factor for 0.5. So just we have to go for the graph, determine the correction factor, and then we multiply U by this correction factor. So as we have seen before, the correction factor for a feed of 0.5 is 0.85. So what we should change in the procedure of the previous problem is to multiply U by 0.85. And of course, we should get the new value of the feed. The removal rate will double, okay? Because the feed rate was doubled. So we can get the value of the removal rate. And then the same procedure for the cutting power. We multiply the value of the removal rate by U, and then to account for the mechanical efficiency and get the gross power, we divide by 0.5. Okay, so here the idea was just to pay attention for the correction factor when the feed is different than 0.25. Another problem, in orthogonal cutting, orthogonal cutting is performed on a metal whose mass specific heat is 1.1 joule per gram Celsius. The density is 2.7 gram per centimeter cube, and the thermal diffusivity is 0.9 centimeter square per second. The following cutting conditions are used. V is equal to 4 meter per second, T0 is 0.3, and omega is 2. The cutting force is measured as 1,000 Newton. Using Cook's equation, determine the cutting temperature if the ambient temperature is 20 degrees. So here it's a simple application of the temperature variation during the cutting operation. Just make sure, here it's delta T. Just pay attention for units. And the main idea here is to pay attention for units, okay? First, you have V is given. It is the cutting speed. It's 4 meter per second. T0 also, it's directly given. It's 0.3 millimeter. Concerning the diffusivity value is given, but you should pay attention for units. So if you are working for V and T0 in millimeter, then put K in millimeter. Because look here, let's say I have meter per second times, so here I have meter per second times T0. Let's say it is in meter. So I will have meter square over second, and I am dividing by K. K unit is, as you can see here, they give it to you in centimeter square per second. So to get same dimension, you should pay attention. Or you convert V and T0 to both to centimeter, or you convert K to meter square per second. And you can put your units here for this ratio, or the 3 will be in meter, or the 3 in millimeter, or the 3 in centimeter. So you should select one of the 3. Because T0, let's say, we are working in millimeter, let's say. So we should convert V to millimeter. You should multiply then by 10 to the power 3. And you should also, T0 is already in millimeter. So you replace T0 by 0.3. You replace V by 4,000. And concerning K, you should pay attention that to convert to millimeter square per second. So since it's 0.9, you should multiply to go from centimeter square to millimeter square. You multiply by 10 to the power 2. Okay, so by 100. So 0.9 will give you 90 millimeters square per second. So you divide here by 90. In this way, the overall unit will be of this term. The unit of this term will be, so it's 1 over second of Vt0 over K. Okay, so Vt0 over K should be in, the unit of this ratio should be 1 over second. Now, in the next step, for U and rho C, okay, U is specific energy, okay, you will get it from the table, and always, since it's an empirical relation, we should respect the units used, and in any empirical relation the units to use are provided. So if you go back to the derivation, to the equation, when they said we have an empirical relation, they specified for you what should be the units to use. So you should respect completely these units. Okay, so they told you in this equation U should be in Newton meter per millimeter cube, and the value of rho C, okay, should be in joule per millimeter cube. So you should pay attention for this. Hala, in case you want to change, you should pay attention. If I put here in meter cube, also rho C should be in joule per meter cube, because at the end millimeter cube will be simplified. Okay, but to avoid confusion, respect the units I asked for. Okay. Here, for example, they said you can use K in meter square per second. In this case, you should pay attention that V should be in meter per second and T0 should be in meter. So if you selected V in millimeter, let's say, it's not wrong, but you should pay attention also to put T0 in meter and to put here in millimeter and to put here K in millimeter square. So it's not wrong if you want to use other units, but you should be, they should be in a way to simplify to get the same result at the end. Okay, because at the end with the units given here, Vt0 over K should be in 1 over second, and U over rho C, this ratio should be in, because you have U as Newton meter over millimeter cube, and rho C should be in joule per millimeter cube. So as you can see here, the unit should be should simplify. Okay, so here if you use Newton meter and joule will simplify, and millimeter cube will simplify. So if you choose to work with U in Newton per meter cube, also rho C should be in joule per meter cube. Yes.
دكتور مش الريشيو VT0 over K شو dimensionless؟
مبلا sorry, it's dimensionless exactly لأنه feet over second. Yes, مظبوط. It's 1. It's without unit exactly, because you have meter per second نسينا نزيد per second. Yes, exactly. So it's meter per second. So meter square per second over meter square per second. So it's without unit. Okay. So here this ratio is without unit, and this ratio also should be without unit. So we should do in a way to have simplification of units. Okay. So now, if I go back to the equation, okay. So here, since I choose for V millimeter and for T0 millimeter, so I get millimeter square per second, then K also should be in millimeter square per second, so that unit simplify. And the same for U over rho C, okay. So I will get simplification of units. Then here, I will use for U Newton meter over millimeter cube, and I will use for rho C the same joule per millimeter cube degrees. Okay, so now what is missing for me is the value. They give me everything. Okay, they gave me rho C in. So if you check the unit here, okay, I have it in the specific heat is given, okay, in joule per gram Celsius, and the density is given in gram per centimeter cube. So here I should multiply, when I multiply rho times C, gram will be simplified, okay, and I will get my result in joule per Celsius centimeter cube, Okay, I should pay attention here also that I should convert to millimeter cube because the value of internal energy I get is in millimeter cube, is in Newton meter per millimeter cube. Okay, so now to get U, I should see what is the type of material used. The type of material used here is performed on a metal. Okay, they didn't give me the type to get U. But I can get U because I can get it from knowing the cutting force. Okay, so sometimes if they don't give you the material, I can find it from another way. We know that in this problem, they gave us the value of the cutting force. Okay, so we know the cutting force, and we know by definition that the internal energy or specific energy, the specific energy is given by the ratio of the cutting power over the removal rate. Okay, and I can derive another formula for the specific energy by replacing the power. So if I multiply here, for example, you know that the removal rate is given by which relation? It's V times T0 times omega. Okay, so let's say in this case I can replace. We know that in order to calculate the power, okay, the power I can replace it by the cutting force times V. So if I replace the cutting power by F cutting times V, and I replace the removal rate by its expression VT0 omega, I can simplify V and say that the specific energy can be calculated by Fc over T0 omega. So the specific energy can be found by calculation or can be found from the table. But since here the table, the material is not, the type of material is not provided, then I should go to the formulas. Okay. Now the cutting force is provided in Newton, and since I want to have U in Newton meter per millimeter square. Okay, or if you want, I can work here directly in meter if you want. And overall, I will get Newton meter over meter cube, and then to have same units, I should go then for the rho C. Rho C also should be in joule per meter cube. Okay, so I can do this here because I have already my force in Newton. And to have the unit Newton per meter cube, all I have per meter square, لأنه meter and over meter cube will give you meter square. I can put T0 and omega in meter. Okay? Or you can play with unit as you want. Just make sure to have the same units for U and for the other term, which is rho C. Okay? So here, for example, they choose to work in Newton meter per millimeter cube. So this is why they used, for the velocity, they used the unit of meter per second. Okay. So while here, here, if you want, they used for the velocity in PC times V, and PC times velocity, حطوا unit of velocity meter per second. While the removal rate, حطوا velocity in millimeter per second. Why they did this? To obtain at the end the result in Newton meter per millimeter cube. You can do this, or as I told you, you can find the result in Newton per meter square. وساعتها you convert rho C to have rho C in the corresponding unit. يعني بدها تكون for UC بدل ما تكون الفاليو in نحن عادة بنعملها per millimeter cube, you can convert it to meter in this case. Okay, so now for rho C, you have it here in joule. كمان هون بدنا ننتبه لليونت لأنه الرو is in gram per centimeter cube. When you multiply it by C اللي هي joule per gram Celsius, you will get that the gram will be simplified and your final result will be in joule per centimeter cube degrees. هلا in case انتم جايبين اليو يعني نيوتن per meter square، ساعتها هون لازم حول لمتر. وإن case you found U in Newton meter per millimeter cube, ساعتها you will convert from centimeter cube to millimeter cube. Since they got U in Newton meter per millimeter cube, ساعتها I want for the density, I want to convert from centimeter cube to millimeter cube. So since here at the lower part of the term, I should multiply by 10 minus 3, okay, to convert from 1 over centimeter cube to 1 over millimeter cube. I should multiply by 10 minus 3. So I get the value of rho c. And now I am ready to replace, okay. Just please pay attention. هيدي الفورمولا ما بتعطيكم t، بتعطيكم delta t. يعني هيدي delta t. So if you want to obtain t, you should calculate this factor and you should add to it plus ambient temperature, plus T ambient, okay? So this is what they did. They calculated the value of delta T and they added to it the ambient temperature to get the total temperature in degrees. إجباري حتكون temperature in degrees لأنه هون rho C is expressed by over degrees, okay. وهي it's at this side, so بتطلع الديجريز لفوق. بيطلع الاوفرول يونت بتكون ديجريز لانه اليونت of rho و UC are the same، يعني بيبقى منهم بس الديجريز when you simplify here. وال VT0 over K without unit، فبتطلع اليونت للاوفرول بتطلع ديجريز. Okay. Any question on this? So hopefully next time I will post for you recordings for chapter 18, and hopefully on Wednesday we start problems for chapter 18. Okay? See you next time. Bye bye.
Okay.